Chapter 14, Summarizing Data Numerically. Section 14.1, Measures of Center. I'm going to go ahead and just jump right in with an example. 9 friends go out to lunch together. The amount of money in dollars each one brought is shown in the table below. So we have somebody with 4, 12, 18, 10, 13, 6, 7, 0, and 55. And there's always one, right? Seems like you go out with a bunch of friends, somebody always managed to get out there with no money on them. All right, so let's find the mean of this data set and what does it represent. So the mean of a data set is just the average of a data set. And if we consider this to be a sample, then the symbol we would use for that is the sample mean, and that is an X bar. And the way that you get an average is you add up all the data values. The way we write that in statistics is we use this capital Greek letter sigma to represent the sum. We put an X sub I to represent the x1, x2, x3, x4, x5, x6, x7, x8, x9. So the little I we call an index. A lot of times people don't write the index and they just put sigma x. So you'll see both. And then we divide that by the size of our sample, which is the number of people that we have going out to lunch here, which is 9 on this problem, but in general we use the lowercase n. So when we're asked to find the mean, we're just calculating the average, and this is the symbols that go with it. We call it X bar, that's a sample mean, and then we add up all the data and we divide by the number of data values. All right, so this is fairly straightforward to do, something that we've been doing for a long time in our math careers, finding averages. So we'll just add up all the values first. So 4 plus 12 plus 18 and so on. A little silly to add the 0, I guess. Didn't change anything, but it is one of our numbers. So 125, and then we divide by the number of people, which is 9. That's probably going to be messy. So 125 divided by 9 is approximately, I'm going to put units on it. This was dollars, so $13.89 if I rounded that to the nearest penny. All right, so now I want you to think about this question right here. What does that represent? So what I want you to think about is not just that it's the average, but like, what does this mean to this group of 9 friends? What does it tell them? And I think it's a little trickier than you might think, so I'd actually like you to pause the video and try and come up with an answer for yourself. What does this represent for the 9 friends? All right, hopefully you thought about that a bit. One of the things that people often tell me is that tells them how much each person can spend, which I think is interesting because we have a lot of people who don't have that money. I mean, how's this person who brought $7 going to spend $13.89? They don't have that. So I would argue this kind of almost doesn't represent anything. I mean, what it does represent, if you wanted to get down to it, is the amount each person could spend if they shared the money equally. But that's a big if, right? Is this person willing to just throw all their money into the pool and split it with everybody? So this is the amount per person that they can spend for lunch. I'll leave that phrase off in the writing. If, and a big if they share all the money. So because of that, sometimes they call the mean the fair share value, but is it really fair? Is that person going to think it's fair? I don't know. So I think this is interesting because instructors a lot of times when they give a test back will tell you what the mean was on a test. So what does the mean on a test tell you? Well, that's the amount of points per person if we share all the points. But I've never heard of a teacher sharing all the points among the class, and it probably wouldn't go well if they did. So there's times where averages are useful, and it's when the total is useful. I mean, if they were in some sort of emergency and they needed to get, rent a car to get home, then the total amount of money they had would matter. But when they're just going to lunch and they're probably not going to share all the money, the average isn't necessarily so useful. And another thing that people will often think about the average is that it splits the data set into like a lower half and a bottom half, so it's kind of like in the middle. Turns out that's not true either, and we'll see that a little bit further down the page. First though, let's look at another item called the median, and what does that represent? So the median of a data set is the value in the middle, but it's the middle if you put the data set in order. So if I want to find the median, the first thing I do is put the data set in order. So we have the person with 0, and then the 4, and the 6 and the 7. So I got those, and then let's see, 10, 12, 13. Make sure I'm not missing anything here. 10, 12, 13, got all those, and 18 and 55. So if you put the data set in order and you look, it looks like this value right there would be in the middle. There's 4 below it, there's 4 after it, so that's in the middle. So the median, we often use a capital M for, and in this case, that would be a 10. And I guess $10, right? So the median is $10. And what does that represent? It's the middle amount of money. Sometimes we say it's the typical amount of money people brought. And then it's a little vague, but I would say it allows top half, bottom half comparisons. And you'll see why I want to bring that up in just a second. But what I mean by that, it allows top half, bottom half comparisons, is if you brought $12, because you're above the median, you know you were in the top half of the money bringers. If you brought $6 or $7, that's smaller than 10, you know you were in the bottom half. I would argue that this is the number that teachers should give when they give a test back, because that way, if your score was above the median, you'd know you were in the top half of the class. And if it was below the median, you'd be in the bottom half. But the average doesn't work for that, and that gets pointed out by this question right here. What percentage of the people have a below average amount of money? If you ask that for the median, typically that's going to be an answer around 50%. But what do we mean by below average? Well, the average was $13.89, so anybody that had less than that was below average. We can see that probably best in this ordered list of the data. Only the $18 and the 55 are above average, so the other 7, including the 13, which is just a little below $13.89, all 7 of those are below average. So 7 out of 9 have a below average amount of money, and as a decimal, if you put that in the calculator, you'll see it's repeating 7s, so that would be 0.7778 or 77.78%. So people have this misconception about the average, that it splits the data set into a bottom half and a top half. But in the case of these people heading out to lunch, the average actually splits the data set into a lower 77.78% and an upper 22.22%. So it's not a 50-50 split at all. And that has to do with the fact that the mean can be skewed by outliers. Now, outliers is a value that kind of stands apart from the rest. Now, in this list, nothing seems to be obviously standing apart, but this person with $55 brought a lot more money than anybody else, and so we refer to that as an outlier. If we saw this in a graph, you'd see this point is lying out far away from the rest. And what happens if we made that outlier worse? What if instead of $55, that person had brought $555? Then what effect would that have on the mean and the median? So let me go ahead and make that change by throwing in $500 bills for this person, which would mean they now have $555. So I just threw that in with that red 5 right there, okay? So let's do the median first. The median would be the middle value. And when you give more money to the person who already had the most, it doesn't change the order, so that 10 is still in the middle. So it appears that making the biggest number bigger has no effect whatsoever on the median. But how about on the mean? Well, you'd want to add up all the values, right? So it's all the money we had before, 125, plus the 500 extra dollars this person now has. So now our total, if you add all those up, should be $625 divided by 9. And does that affect the average? And for sure, because there's different numbers in the calculation. Now, instead of $13.89 per person, it's $69.44 per person. And now I guess if you've gone out to lunch with that group, you really hope that that person is wanting to share the money equally with everybody, because now you can have a pretty nice lunch, it appears. So the key thing here isn't about whether you get a better lunch or not, because again, they're probably not going to share all that money anyways. But what I want you to see is that the median is not affected by making the outlier bigger and the mean is. Okay, and we'll summarize that on the next page. But let's start summarizing a bunch of the stuff we've done here. So one of the things we computed was the sample mean, also called the arithmetic mean. Not super common that we would use that phrase, but it's another word for it. And if your data values are x1, x2 through xn, so you have n sample values, then your x bar or sample mean is the sum of those x values divided by the number of values you had. So in words, the mean is the sum of the observations divided by the total number of observations. So that's the mean. Let's go ahead and turn the page and look at median and also a new term. All right, so as I mentioned before, the median, we use a capital M for that, and the median of a sample of data values is the same thing as the 50th percentile. So we've talked about that a little bit, but these are the exact same things. So if you get asked for the median or the 50th percentile, you'd calculate the same thing either way. And to find the median, the data set must first be put in numerical order. So you can't just pick out the value that's in the middle of the set if the set is all kind of scrambled. It's got to be in numerical order first. But after you put it in order, then how you find the median depends on whether you have an odd or an even amount of values. So if the number of observations is odd, which is the example we saw on the previous page, then the median is the middle observation. And if the number of observations is even, then the median is the mean of the two middle observations. So when you have an even list, and we'll see that on the next page, there's not a true middle, but there will be two that are kind of tied for the middle, and we'll average those or take the mean of them. And then we say that the mean is sensitive to outliers because the mean is pulled or skewed in the direction of those outliers. So we saw that with the $55. But that does not happen with the median, so we say the median is resistant to the effect of outliers in a data set. And then we're also going to have a new definition called the mode. We haven't seen that one yet because it didn't really apply very well to our last data set, but the mode of a sample data set is the observation with the greatest frequency. So it's the one that shows up the most times. And there can be more than one mode, so it can be a tie. Like if something shows up 8 times, but another data value also shows up 8 times, and that's the most, then they would both be modes. But if all the observations have a frequency of 1, so if there is no repeats at all, then we say there's no mode. Occasionally I've seen books that say then every number is a mode, but it's more common to say when there's no repeats, there's no mode. All right, so now this picture down here shows a relationship between the peak of the graph of data and how that relates to the mean, the median, and the mode. But they didn't say that on this graph, but it only applies to single peak graphs. So it can be a little different if there's multiple peaks. So if your data, if it was graphed, only has a single peak to it, then this will be true. The mode on a graph is often referred to as the peak. So if you thought about it, like if you stack numbers on top of each other, that would be the one that stacked up the highest. So it kind of makes sense to call the peak the mode, the most repeated one, right? And if you have a data set that is left skewed, which means you have this tail off to the left, then your outliers are on the left, then the mean will get pulled towards those outliers. The median will be to the left just because the halfway mark will be on the left on this type of graph, and the mode will be at the peak. What I mainly want to focus on is the mean and median. If you have outliers only on the left, which makes this left skewed graph, it's called that because the mean is being pulled to the left of the median. So you can tell you have a left skewed distribution if your mean is smaller than the median. And the opposite is true if it's right skewed. Right skewed will have outliers on the right that are pulling the mean to the right, but they don't affect the median, so the mean gets pulled to the right. And I guess to kind of compare that, if you had a single peak and it was symmetric, the mean, median, and mode would all be in the same place. But once you start getting outliers on one side, the mean gets pulled to the right of the median. If the outliers are on the left, the mean gets pulled to the left of the median. So let's see if we can try and sort some of that out with this example below. Which of the graphs below could have a mean of 65, mean of 65 and a median of 75. So let's see, 65 is less than 75. So what we have here is the mean is less than the median. If it was symmetric, they would be the same, but the mean has been pulled to the left because it's smaller. So that means that we must have this left skewed situation if the mean is to the left of the median, or if the mean is smaller than the median. So which graph does that leave for us? Well, we have two symmetric ones. Those aren't the ones. And then we have right skewed outliers on the right, left skewed outliers on the left. This one makes the most sense. So if we're bubbling in, which they seem to want us to do, it would be that one, part A. Because again, if the mean is smaller than the median, then that represents a left skewed shape, and that means peak on the right, outliers or short bars on the left, and this is the only graph that has that feature. All right, we're going to go ahead and look at one final example, both so we can see an example of the mode and then also just get another run through on the mean and median, especially with an even number of data values. So an intermediate algebra class completed a chapter quiz using an online homework system. The time in minutes spent by each of the 18 students on the assignment is shown below, and we wish to summarize the time for these students. So let's calculate the mean for the data set, and the median for the data set, and the mode for the data set. All right, so if we want to calculate the mean for the data set, then we're going to do x bar. It's going to be the sum of those x values, and then we're going to divide it by the number of x values. So the first thing we would need to do is add up all the data. And I want to go ahead and show you a little bit of a shortcut for that on the calculator. I mean, it's not that hard to do. It's just a little tedious normally, right? Just add all 18 of those up. But we can do something to speed up the process a little bit. So we can enter all that data into the calculator, just like we have done when we were doing regression and stuff like that. So just enter all those values into list 1, and I've already done that to save a little bit of time. And then when you want to add them up, that is a feature the calculator can do for you. So what I'm going to do is I'm going to arrow over into list 2, and I'm going to choose the list menu, which is above the stat key, so second and list. And I want to do some math on one of those list columns. So I'm going to go over to math, and I'm going to choose sum because I want to add those values up. And then what do I want the sum of? I want the sum of this column, list 1, so I'm going to hit second and list 1. And that's going to put that in the first entry in this other column. Make sure you do not have the L2 highlighted because that won't work. You need to be in the first square like you were entering a piece of data. But if I do that, it adds up all the data values for me. So 667. And then they already told me that there were 18 data values or 18 students. So I can divide by 18, and then that will give me the mean. So let me go ahead and exit out of here. 667 divided by 18 is approximately 37.06. And then what were these? I think they were minutes. Yeah, the time in minutes. So 37.06 minutes would be the mean for that data set. Now let's calculate the median. And this is where the calculator is going to come in handy again, because the first thing you're supposed to do when you calculate the median of a data set is put it in order. And that can be a little bit of a pain for a bigger data set. So let me show you how to do that on the calculator. If we hit Stat and Edit, we see our list over here, all just kind of in the order that it came in. I entered them vertically. You could have done it horizontally. It doesn't really matter. But the data is not in order. Okay, so how do you put it in order? Press Stat. Choose sort ascending or descending. Ascending is small to large. Descending is from large to small. So sort ascending is probably best, so it doesn't technically matter for the median. And then what list do I want to sort? Well, I put all the data into L1, so I'll hit second L1. When I press enter, it'll just say done. But if I go back and do stat and edit, we'll see that the data set is in order now. So I guess we could copy it down and try and spot the middle number. It's hard to spot the middle number here because you can't actually see all the numbers at once, so visually it's hard to lock in on what's the middle. So we have a little trick for that. So to calculate the median of the data set, what we do first is figure out what is the location or position of the median. So the location of the median is going to be 1/2 of the way through the data set, and you calculate that by doing the number of data values plus 1. So what I'm going to do here is n plus 1 in general, and in this case that would be 1/2, I guess a little n, 1/2 times 18 plus 1. So if you do that, that's 19 in the parentheses divided by 2, is 9.5. So if that was a whole number like 9, it would mean the median was the 9th number. If it was a whole number like 10, it would mean the median is the 10th number. When it's a decimal, what you need to do to find the median is average the 9th and 10th values. So we want to find the 9th number here, 10th number there, and then divide those by 2. So one of the things that's nice about having done this on the calculator is any value that's highlighted is numbered. So that's the 6th number in L1. So if I want the 9th number, I just arrow down until it says list 1, number 9. That's 41. And the 10th number is also 41. So when I average the two 41s, I of course get 41. Okay, so this formula is kind of handy for locating the median, that you go halfway through the number of values plus 1. All right, before we move on to part C, I want to go ahead and do a couple quick things. One of them is this formula, why it works isn't maybe entirely clear at first, but I want to show you that it does work by going back to the example we did earlier where it was intuitive for us. So in this set, our median was the number 10 because it had 4 numbers below it and 4 above it, and we could kind of see visually that that was right. If we wanted to use this formula, the location of the median, we would do 1/2 times the number of data values, which was 9 plus 1, and divide by 2. So 9 plus 1 is 10, divide by 2 is 5. So what the formula is telling us is the median is the 5th number, and if we go 1, 2, 3, 4, 5, there it is, the number we had already picked out. So the plus 1 may seem a little strange, like where did that come from, but notice adding the plus 1 does give us the correct value of the median. And then the other thing I wanted to do for you, since we did some calculator stuff, is just summarize where those things were. So if you want to get the sum of the x values in your calculator, then the pathway to that is to go into list, and then we chose math, and then we were able to pick sum, and then we put our list number. Okay. And then here we sorted the data for this one. So if you want to do that, for that one we hit the stat key. So this is to sort data. You'd hit the stat key, and then when you're in there, the first option in the edit menu, I'll go ahead and write edit, but that'll be kind of automatic that you're in the edit menu, and you want sort ascending, small to large, and then tell it L1. Okay, so those are the new calculator things we did. All right, so now let's go ahead and keep moving on with this example. So let's find the mode for this data set. So that's the most repeated number. So you could just go looking through for repeats, and I see like 41's repeated, 46 is repeated. So I can see some repeats there. But the easiest way to see those repeats is when your data set is already sorted, is those repeats are going to be right next to each other. So pull that in and just arrow through looking for repeats. So 41 is repeated, so 41 might be the mode. And then 46 is repeated 3 times, so now that's kind of taken over the lead. It's not just any repeated number, it's the most repeated number, and 46 shows up 3 times. So right now that looks like the mode. And then 50 is repeated but only twice. So if there was one less 46, then we'd have 3 modes, 41, 46, and 50, because they would all be repeated twice. But there's one more 46 than the others, so that one is kind of the king all on its own. So the mode for this data set would be 46. All right, now in these chapters and sections on measures of center, they always throw mean, median, and mode in together. But one of the things to know about the mode is it could actually be anywhere. The mode could be the min, the max. It's not necessarily in the center, but they traditionally do these 3 all at once. All right, so let's go ahead and see what else they have for us here. Would you describe the data set as left skewed, right skewed, or roughly symmetric? All right, so let me bring in that previous page. So if it was roughly symmetric, the mean, median, and mode would all be the same. So let's see, we've got 37.06, 41, and 46. Those are not all the same. If they're all real close to each other, I might say roughly symmetric, but they seem kind of different. So then it's probably one of these two. So it depends on whether the mean is bigger than the median, that would be right skewed, or if the mean is smaller than the median, that would be left skewed. So what do we have here? Where is our mean? Our mean x bar is 37.06, and our median is 41. So which one's bigger? The median's bigger. So how does the mean compare to the median? The mean is smaller than the median. And again, let's bring that up. If the mean is smaller or to the left of the median, that's because of outliers on the left pulling or skewing the mean in that direction. And so we'd say that this is left skewed. Now, I did that entirely based on just comparing the mean to the median, but one of the things that I did earlier is I set up on the calculator to be able to graph that data in a histogram form. And notice that our peak is on the right, and then the short bars and kind of outliers are over here on the left. So these short bars to the left of the peak are pulling the mean in that direction. So it kind of works visually, but they're intending for us to answer that numerically. All right, and then let's see what else they've got. Which of the three measures of center is most appropriate to use to explain to a student how long they should expect to spend on the quiz, right? So a student comes up to me and they're like, on this quiz we're about to take, based on your experience from, last semester or something, how long do you think it should take me to take it? Well, I could give them the mean, but the mean is affected by outliers. So if there's somebody who was really fast or really slow, that can really distort that, and that's just one person. And it's not like we're going to share the minutes, so the mean isn't useful in that regard either. The fair share doesn't apply. But the median is a halfway point. The mode I mentioned before could be anywhere. In this case, the mode is kind of towards the right. It's a longer than usual time. So I would give them the median, because then I could tell them, like, look, if you're a slow student, it'll probably take you less than or more than 41 minutes. If you're a fast student, it'll be less than 41 minutes, because 41 is kind of the middle. So which would I give them? I would give them the median. And then they could think about whether they are normally one of the fast students or the slow students. Right, I think students should have a sense of that because they've taken tests in class with other people, and they know if they're usually one of the first ones done or one of the last ones done, or kind of in the middle. So if they're kind of near the middle, they would probably take about 41 minutes. If they're usually one of the first to go, it's going to be less than that. If they're usually one of the last to go, it's going to be longer than that. But the average isn't in the middle, so the average isn't a good comparison point, and the mode could be anywhere. And the mode could be just two people with the same thing. In this case, it happens to be 3, but 3 out of 18, right? So I think it's better to use the median. It gives a better overall sense of what's going on. All right, and then the last question they have for us, what is the value of the sum of the xi's, and what does it represent in terms of this application? So the sum of the xi's was the numerator of our average, so we can first just say what it was. The sum of the xi's is equal to 667. And then what was that? Well, these were the minutes spent per student. There were 18 students, so this was the total amount of time that the 18 students spent. So it was the total quiz time for all 18 students combined. All right, so there we have an example looking at mean, median, and mode, how those affect whether things are skewed, and kind of some decision making about which one would you tell people in different situations. All right, that wraps up this section.